Question 1 of review sheet G is 12 things to differentiate using the product and quotient rules. I'm not going to do all of them, they're just repetitive, so I'll just show this middle row. I'm not going to write square root of x here, I'm going to write x to the half. The other one is the quadratic that you see there. Differentiating each side individually gives you a half x to the minus a half here, and here we've just got 2x plus 2, haven't we? And the product rule is these two bits times together, times by x squared plus 2x minus 5, plus, the product rule is plus these two bits times together, times by x to the half. I'm not going to tidy that up, I'll just leave it like that. For E here then, we've got U is the first part of just the x cubed, that differentiates very nicely from the first U work. But V is ln x, and that's one of the new ones. You just learnt that ln x goes to 1 over x. So the crissy-crossy part of that is that 3x squared ln x plus these two bits times together, x cubed times by 1 over x, just cancel one of the powers to give you an x squared on the end there. So there's the second part of that one. Rolling down a bit so we can get some more space then. So H is now and I'll change colour as well so you can see this. So H is now a quotient rule. So I've got x to the power of 8 for this, giving me 8x to the power of 7. On the bottom, the V is always the bottom part, and that nicely just differentiates to 1, doesn't it? And so the rule is V du dx, those two bits times together, minus u dv dx, those two bits times together, over 8, all over v squared. We could tidy that up here, I suppose, couldn't we? That we can see here I've got 8x to the 8s here, take away that one, so I've got 7x to the power of 8s here. I've then actually got 56x to the power of 7s, and that's all still divided by x plus 7 all squared. I don't think it's ever really necessary to multiply on the bottom. I rarely see that as anything useful. And this one here then, so this is k. I've got u, always the top bit, that differentiates just to give 4. I've got v as the bottom bit, again I'll write that as x to the half, so I've got a half x to the minus half. And it's v du dx, those two bits times together, minus u dv dx, all over v squared. And I can work out what that squared is. It's just x, isn't it? I suppose there are ways we could tidy that up. But I think, yeah, I mean, there's some multiplying out that's worth doing there, but I'm going to stop there.